Hello, everyone. I'm Diana Bauer. I'm the acting Deputy Director of the Advanced Manufacturing Office at Department of Energy. And I'm here to moderate the energy storage panel this afternoon focused on minerals and materials processing for batteries. So first, I'm going to introduce our panel. We have Joe Bryan, who is the Chief Sustainability Officer for the U.S. Department of Defense and a former senior fellow at the Atlantic Council. Welcome, Joe. We have Gerbrand Cedar, who is the Samsung Distinguished Professor of Engineering at UC Berkeley and a senior faculty scientist at LBNL, where he develops novel materials for energy storage. Hi, Gerd. And then we have Samira Fazili, who is the Deputy Director of the National Economic Council, where she oversees the administration's domestic competitiveness agenda, including efforts to secure an end-to-end domestic supply chain for high-capacity batteries and energy storage. Welcome, Samira. And then we have Kimberly Lavoie, who is the Director General of the Policy and Economic Branch in the Lands and Minerals sector of National Resources Canada, where she is responsible for key areas related to Canada's mining sector. Welcome, Kimberly. And finally, we have Ruby Wen, who is the project lead at the Critical Materials Institute and a group lead of systems, dynamics, and modeling at Idaho National Laboratory. Welcome, everyone. So first, I'll start with Samira. You know, a year ago, we issued, or the federal government issued a supply chain executive order, and then last month issued a series of one-year reports across the whole government. Could you tell us more about the motivation for the executive order and the main challenges and opportunities that you see in battery supply chains?
Sure. You know, I think a year ago when we first issued this executive order, people said, what's a supply chain? And now it's kind of become a kitchen table term and no longer something just reserved for those in business logistics teams. You know, the pandemic really highlighted and magnified a lot of the fragilities and vulnerabilities that that experts had been analyzing in supply chains for many years. You know, most saliently, it came to the fore when we couldn't make masks and basic PPE in this country, and we were suddenly cut off from trading partners. And now, you know, I think we're seeing it again with the crisis in Russia, Ukraine, how just geopolitical events can suddenly be a disruption. So even beginning on the campaign, the president was really focused on this issue, said our supply chains were weak and vulnerable, and put in place this executive order 14017, that said we'll take a product by product approach and a sector by sector approach at really mapping and understanding what our vulnerabilities are, but also where there are opportunities to close those vulnerabilities and shore up America's kind of national security and our economic security, because we recognize that the structure of these supply chains was not just an issue of national security risk, but was actually hurting our economic security and economic competitiveness. Again, I think this year you've really seen that come through when the chip shortage ended up, the global semiconductor shortage ended up driving a third of core inflation here in the U.S. Because it drove a large increases in auto prices and even shaved off some of our GDP potential last year because we weren't able to produce as many autos as otherwise would have been produced. So what we did was, especially in relation to critical minerals and materials, back in June, we released a report focused on the disruptions in the minerals and materials supply chain and developed a blueprint to have us build towards an industrial strategy to create, to build the supply chains link by link in industries that are key to that strategy. we as an administration have set a very ambitious goal on electric vehicles. 50% of all new sales will be electric by 2030. And we think that this is an area where the U.S. has the potential to be globally competitive and even global leaders throughout the EV supply chain. So not just in producing the end vehicles, but we have a lot of mineral assets here in the U.S. that could be valuable to global supply chain. So we've also seen that corporations are themselves thinking about restructuring their global supply chains, and this is a real opportunity. Corporations recognize that to some extent they've underpriced the risk of supply chain disruptions and are trying to shorten and simplify their supply chains because they had underappreciated how cyber risk, extreme weather risk, geopolitical risk could lead to disruptions that would hurt their bottom line. And so as we move forward here on securing the minerals and materials supply chains that are so important to our clean energy goals as a country and to the electric vehicle future, we know it's important to do this right, to do this in the right way, to scale upstream capacity, make sure we've secured minerals and materials, do that in a way that lives up to our values of sustainability and equity, to make sure that workers and communities have a voice to shape the development of these industries. And we also see a real opportunity as this industry is expanding to help develop that full circular economy by pursuing what we call an all of the above strategy here, where we want to mine for the minerals, we want to recycle to secure the minerals, we want to remine to secure these minerals. And you'll see us take an approach here, and you're already seeing us take an approach here where we put funding towards that innovation, like in the bipartisan infrastructure law that was created to help jumpstart the industry, while we also look at places to improve the regulatory and legal environment. Just 2 weeks ago, we announced a working group in principles for mine permitting reforms and oversight of mining processes here in the U.S. And finally, in all of this work that we do, we recognize that we want to work with our allies and partners and really both level the playing field with some competitor nations abroad who we think have subsidized in their domestic industries, engaged in unfair trade practices, but through working with partners and allies, we can create stronger global supply chains and more sustainable markets into the future by organizing ourselves together. So all in all, I would say that for us, our motivation here is really clear that as we can see from recent events, it is so important to our national security and our economic resilience as a nation to have stronger, more resilient, more diverse supply chains that aren't leaving us overly dependent as a nation on one country or region. And we're especially vulnerable when some of these supply chains are overly concentrated in countries that might be adversaries or that pose key geopolitical risks or other kind of risks to the global environment. I'll leave it there.
Thanks so much, Samira. It's great to hear such passion behind supply chains. Joe, Samira talked a bit about national security. I'm wondering if you can add some more specifics about DoD's perspectives. How is DoD affected by the rapidly growing and evolving global and domestic commercial battery market, and what materials extraction and processing needs do you see?
Yeah, well, first of all, thanks, Diana, and I appreciate the opportunity to be on the panel and talk to this group and to share the virtual stage, at least with colleagues from across the government and academia. Now, look, the Department of Defense, I think our situation in many ways mirrors that of the private sector, right? We're seeing more batteries for more applications. And I think that kind of demand has been growing for some time. I mean, look, Department of Navy alone has between 2,000 and 3,000 systems that rely on lithium-ion batteries already. across the Department of Defense, we probably have double the number of systems that rely on some battery technology. So 4,000 or 5,000 systems, or 4,000 or 5,000 different battery types that we put into our systems. And they've been supporting a range of applications for some time. We have, the Navy uses batteries to support underwater unmanned vehicles to do mine detection. We have lithium-ion batteries being put in tactical vehicles to extend range and provide capabilities like silent watch for our tactical vehicles in the battle space. We have high power systems on Navy ships that need batteries. And as we look to the future, we have things like directed energy weapons, and we have hybridization of our tactical platforms. So look, we already have a huge dependence on batteries, including lithium ion, and growing in lithium ion space. And future capability is completely dependent on some of those batteries. So we are in, just like the commercial sector is in. And as we look at our material needs, our supply chain runs where the commercial supply chain runs. It runs right through to Asia as we go upstream. So while we have some obviously domestic cell and packaging capability, as you go further upstream, we have processing gaps and certainly anode cathode production gaps that create risk for us. And so that's a problem, and it's a problem for us. It's obviously a problem for domestic industry as well. And then I think we've all seen, and I'll just put a cap on it by saying, look, the Department of Defense is a big customer, but we are not the auto industry. We use a lot of batteries, but nothing compared to EV industry, right? 17 million cars in America a year. We just can't compete with that. And so, and what we know is that those industries are going to demand a lot of these materials, and we're all going to be competing for the same limited demand or for the same limited supply over the next few years. So the compounding of the compound risk there is, one, we know where the supply chain currently runs. It runs right to Asia as we go upstream. And two, there's a lot of people who are going after that same material. And for us, we need to figure out a way to manage that risk and to make sure that we're supporting the capabilities that we need in order to defend the country. So acutely interested in this, and I think you'll see that some of that discussion and consideration of risk play out in our battery strategies going forward. Thanks.
And I will say, as the representative from the Department of Energy on the panel, we also are very engaged in both batteries for vehicles and batteries for the grid. So yeah, I think we're all thinking about how to scale these supply chains in such a way that they'll be resilient moving forward. Ruby and Kimberly, when Samira sort of talked about the executive order, she underscored critical materials, and I know both of you are very engaged in the critical material space and particularly processing and separations, extraction, processing, and separations. So what do you see as the opportunities and the challenges, and for right now, and also for what is coming when we get this dramatic ramp up from EVs and whatnot globally?
Yeah, thank you, Diana. So before talking about opportunities and challenges, I'd like to talk about some statistics to paint the picture of the U.S. presence in extractions and processing. So we have Eagle Mine in Michigan that extracts nickel and cobalt. We also have another company in Missouri that recovered nickel, copper, and cobalt from mine tailings as part of the Superfund redevelopment initiative. And there's some lithium extraction in Nevada. So in the last 5 years, the total nickel extractions ranges from 14 to 22,000 tons a year. Cobalt is about 500 to 700 tons a year, and lithium is 1,000 to 2,000 tons a year. And so for processing, most of the nickel, cobalt, and lithium concentrates produced in the US are exported to Canada and other countries for processing. There's a facility that produces nickel in the crystalline sulfate form as a byproduct of platinum group metal ores mined in Montana. And there are two companies that produce lithium compounds from imported and domestic sources. So talking about challenges, we are still reliant on import for refined materials. And also because manufacturing has been absent, we're lacking the know-how and the workforce skills to manufacture cost effectively to be globally competitive, as Samira already mentioned. Furthermore, the US mining has been limited due to environmental concerns. For example, the Blackbird mine in Idaho, as part of the Idaho Cobalt Belt, is a Superfund site because historical extraction releases acid that impact water resources, wildlife, and the overall ecosystem. In terms of opportunities, we have a lot of mine tailings from historical extraction that we can process to reduce mining impact. One example is the collaboration between Rio Tinto and Oak Ridge National Lab, funded by the Critical Material Institute, to extract lithium from mine tailings. And for those who are not familiar with the Critical Material Institute, or CMI for short, it is a Department of Energy funded consortium of national labs, universities, and industries working on technical solutions to critical material challenges. So CMI develops innovative technologies to diversify supply, develop substitutes, and enhance recycling in an environmentally friendly manner with cost effectiveness and supply chain consideration in mind. Another opportunity is that consumers are more aware of the environmental impacts of their products. So they start to demand greener processes and they're willing to pay a little more. And as Samira mentioned, companies start to look for supply chain more seriously. And so we start to see more vertically integrated operations. Kimberly?
Thanks, Ruby. And thank you, Diana, for the question. Let me first say how great a pleasure it is to be here today alongside of my very impressive co-panelists. And I would be remiss if I didn't take a moment to acknowledge that it's International Women's Day. So back to the question, I think a lot of the challenges and opportunities faced by Canada are the same as the US. And this is why it's so important for our countries to work together on these issues. And I say that as though we're not, but we really are, including through the Joint Action Plan on Critical Minerals, which was launched in January of 2020. I think there's tremendous economic opportunity associated with the energy transition, not to mention the fact that we all need to reach our collective net zero emission targets. One challenge that we see is how to level the global playing field in terms of environmental, social, and governance performance, known as ESG for short. That and sustainability. In Canada, we've got a clean energy grid and abundant hydroelectric power, which provides an advantage. We've also invested in technologies and set robust regulations that ensure we're a leader in sustainability and labor standards. But unfortunately, many of our competitors abroad do not value these standards and are able to cut corners. So to help introduce a value proposition for critical mineral supply chains in Canada and the US that could help address the current North American gaps in mineral extraction and processing, we see a strong opportunity to work together to enhance global ESG standards and supply chain transparency mechanisms. And I'm very pleased to see that this is a recommendation coming out of last month's supply chain report released by the US Department of Energy. And I'll stop there for now. Thanks.
Thanks, Ruby and Kimberly. I just want to let the audience know that if you want to ask a question, you can type it in, and if we have time, we'll turn to your questions at the end of the panel. But now I'll move on to Gerd and ask you about the role of science and innovation on extraction and processing, particularly as we're moving ahead in the environmentally sustainable arena. Gerd?
Yeah, thank you, Diana, for that question. I think that lithium ion, which is a technology for which 2 US scientists got the Nobel Prize 2 years ago, is a remarkable technology to address the challenges we have for cleaning up the grid, for electrifying transportation. It's viable, it's reliable, it's cost effective. For those of us in the field, when we started, lithium ion was $2,000 per kilowatt hour of storage. Today it's $100, and it's on a trajectory to go even lower and frankly drop below the cost of things like pumped hydro. So it's a remarkable technology. But to satisfy the need we're going to have for energy storage, we will not get there with the current minerals that we use, with the current supply chain, and we will certainly not get there with relying on nickel and cobalt. We will need multiple millions of tons of metal. Cobalt is produced at about a couple 100,000 tons in geographically concentrated areas, regimes that we're not particularly fond of or not particularly stable. As I joke, is always only one coup away from a supply chain interruption. Nickel, which we used to think was better, doesn't look much better. While we produce a couple million ton today, most of that goes to stainless steel. We would have to increase nickel production multifold by multiple million tons to satisfy the need for electrical energy storage. And if you want to see how vulnerable we are, I ask you to Google the price of nickel today. It went up by 40–50% because of the issues with Russia, which is the third largest producer of nickel. So what we really need is lithium ion. The last part that is needed is lithium ion from earth abundant materials. And that's where science and the national lab system has come in. The Department of Energy at the national labs, and in particular at Lawrence Berkeley Lab, has funded for multiple years research in this area. And that has led to what are called DRX cathodes, which rather than rely on nickel and cobalt, can now use most of the periodic table and can use inexpensive minerals like manganese oxide, iron oxides, titanium oxides. And Gen 1 materials are being put forward now to transfer for scale up and going to industry. So we do have the potential to build lithium ion from earth abundant minerals and with a domestic supply chain. But we need to do more. I think that to transfer things to industry, we need to work faster. We need to work sometimes better, have more information so that scale up doesn't take 10 years. And so LBNL and the rest of the national lab system are working on novel ways to do research through user facilities, but also through novel things like robotic labs that use AI and machine learning to just do things faster and get faster to an answer for novel battery materials. So I think this is a kind of a fascinating time. And my parting message is that, we are getting close. The technology is coming. It is out there to start working with more earth abundant materials in this space.
Thanks. So thinking about sources of materials, another potential source of materials is recycling. So I'm wondering if Ruby and Joe, if you can talk about kind of where there are opportunities to scale up our recycling and how you see recycling as kind of fitting in with conventional material production. Ruby?
Yeah, I think it's true that if we have a strong recycling industry, there's less need for mining. And within Resell, a consortium funded by VTO and CMI, we have looked into recycling opportunities. But we need to keep in mind that there needs to be 4 things to happen for recycling to have major impacts. So the first thing is we need an effective reverse logistics system to collect as much end-of-life products as possible. Because for most recycling, the biggest loss is in the collection process. So I'm hoping that because end-of-life batteries are considered hazardous waste, so the collection rate is close to 100%. We also need to have domestic manufacturing. So right now, for a lot of other critical materials, because we don't have manufacturing of the end products. So once we recycle, we have to export that material somewhere else, which increases the carbon footprint and also the cost of recycled products. The third thing is that recycling technologies need to be adaptive because battery chemistry keeps changing to reduce the critical material content. Recycling is not always profitable. So the ability to operate in a modular manner is important to deal with feedstock fluctuation in both quantity and material content. And finally, we all know that because battery lifetime is long, the feedstock rate can't keep up with the new demand. which means mining is still needed. So theoretically, only when demand reaches equilibrium, then recycling can have a major impact. Joe?
Yeah, thanks. Well, those are excellent points, and I think it actually speaks to sort of the role of Department of Defense in meeting our own battery needs, and that we just have to be, in order to support sustainable recycling, in order to support a sustainable supply of batteries for ourselves, we really need to just be a better customer. In some ways, like I said at the onset, we have thousands of different systems that require thousands of different specialty battery types. And that's challenging for us as a customer. It's also challenging for the market to create a stable source of supply for us. So we need to do a few things. We need to standardize the kinds of batteries we use to the greatest extent possible. That may mean making compromises on terms of specific specialized capabilities. That will allow us to aggregate. Number two, aggregating that demand so that we can both keep our costs in order and to create better supply relationships with companies. And I think that'll help us with the domestic supply chain. And then the third thing I think we need to do is we need to align with industry. Look, there's hundreds of billions of dollars being invested in commercial industry and battery innovation and in battery production and material production. We really need to figure out how we can, to the greatest extent possible, leverage the innovation that's happening there and those investments to feed our own capabilities. So I think that's true of our own battery supplies. It also happens to be true of how you're going to support, I think, a sustainable recycling industry as well, that you get standardized products that people can process in a way that allows them to run a business.
So Kimberly and Samira, we've been talking mostly domestically, though we've talked a little bit about global supply chains. I'm just wondering how we can work together across countries, across allies, on these challenges.
Maybe I can start, Samira.
Yeah.
So thanks for the question. And when our respective leaders committed to developing a joint action plan on critical minerals way back in 2019, seems like years ago now, it was with the understanding that we needed to build on existing integration in the sector. And in 2020, bilateral mineral trade was valued at over 95 billion between our countries. Canada is already an established supplier of battery minerals for the US, such as nickel, graphite, and cobalt, and Ruby spoke about this earlier. Canada's mining sector is also an important source of investment and jobs, with nearly 300 Canadian mining companies operating across the US. This includes London Mining Corporation, which operates the Eagle Nickel Mine in Michigan that Ruby mentioned, and that nickel concentrate is sent to Canada for refining. It also includes Electra, formerly known as First Cobalt, that is advancing its cobalt deposit in Idaho, while also recommissioning its refinery in Canada. And that's the only permitted cobalt refinery in North America. Our supply chains are already, they're deeply integrated, certainly in the auto sector, and that's reinforced by regional content requirements in our trade agreement. And in fact, just recently, German-based BASF signed an agreement to secure land for a cathode active materials and recycling site in Bécancour, Quebec, to increase its North American footprint for battery materials markets. At the same time, General Motors and South Korea's POSCO Chemical also announced a deal to build a plant in that same location to produce materials for electric vehicle batteries, turning the region into a true battery hub for North America. Under our joint action plan, we have an opportunity to work more closely together to support joint products and projects that are of mutual interest. We can also build on long-standing federal research partnerships to advance innovation in areas like minerals recycling and energy storage. And finally, we can demonstrate global leadership in promoting new policies needed to meet the unique logistic needs of the materials and processing portions of a sustainable supply chain together. Over to you, Samira.
Thank you so much, Kimberly. I couldn't agree more and reaffirm everything that Kimberly said, not just for our bilateral relationship with the Canadians, but also just broadly how we're thinking about this as an American government, because we recognize that it's not desirable or feasible for us to onshore every supply chain in the US. There's great value to our economy to continue global integration, especially in coordination with partners and allies, because that's the route to secure, sustainable, and resilient supply chains at the end of the day. I think you've heard many of the panelists speak to how do we create and sustain market forces for sustainability, for reliability, and for resilience. That only happens if we develop more alignment between major consumers of these goods, major consuming nations, which is one way in which we're approaching this. We know in this space in particular, there are going to be some goods we're never going to produce here in the U.S., or we're never going to produce enough quite to meet our demand, like cobalt, as we talked about. The way that we are able to reduce our exposure to some of the riskier countries and nations in the supply chain is through working with partners like the Canadians and the Europeans and others. What you've seen us do in particular is advanced supply chain related dialogues in a number of our multilateral and bilateral forums. Kimberly laid out a few in relation to the Canadians, but with the Europeans, we have a new Trade and Technology Council as well, and we set up a set of working groups to focus on different supply chain related challenges, and critical minerals and materials was one of them. And in these bodies, we'll be able to coordinate not just on science and technology policy and further research coordination, but also look at ways to align things like our bilateral investment tools. Like, for example, we look at the U.S. International Development Finance Corporation and the investments that it can make in sustainable mineral and material operations. When we combine that and combine our funding with bilateral aid or bilateral funding mechanisms that other countries have, is a way that we really can accelerate the production of new markets overseas.
Thanks so much. Thanks so much, Samira. It's great to have such enthusiasm and such detail from all corners of government, both in the US and in Canada, on this very important topic. So I think we'll have to close the session. Yep, go ahead.
No, I'll close with one more thought there. And I think that, you look at the events of the past month and you see that the U.S. is strongly committed to being a partner who brings together all our allies and partners to take coordinated action in a way that, people didn't see us playing that role, a year ago, but now we're here, we're at the table, and it's a real testament to the Biden administration's commitment to global coordination and partnership.
Thanks, everyone.
Thank you.
Thank you.